So this is the video on correlation coefficient. How do we get our R? Okay, so again, this video we're calculating R. So again, I always write my formulas just so I know I'm on the right track. So here we have R equals, again, the squiggly line, which means the sum of, and it's the cross products of Zx times Zy, okay? And all that over N. And as you can see, I have my mean, my z-score formula, how to change a raw score to a z-score, my variance, and my standard deviation, okay? So here's our problem, and here's our two data sets. So you can label this one as x, and this one can be our y, okay? Again, we're looking for a correlation coefficient. So I did a lot of the work already to save me some time. So I'll just go ahead and explain, okay? So again, here we have our x, so we have a 4, a 6, an 8, and a 2. So the first thing we do is we get our mean, okay? So we're looking for our mean, and again, our formula is m equals the sum of x over n. So we're going to add 4, 6, 8, and 2, okay? And when we do that, we do get 20. So we plug it into the formula, so we put 20 up here, and then we divide by n. And again, our n is 4. So 20 over 4, we get m equals 5. So our mean is 5. So we got our mean already. The next step is to get our variance. We need to get our variance and our standard deviation, okay? Because we need to switch all of these scores to z-scores, okay? All of these raw scores to z-scores so we can go ahead and calculate our correlation coefficient, okay? So again, now we're looking for our variance. So it's st squared equals the sum of x minus m squared over n. So here again, we have our x. Now all we do is subtract the mean. 4 minus 5, we get negative 1. 6 minus 5, we get 1. 8 minus 5, we get 3. And 2 minus 5, we get negative 3, okay? I am going again a little bit faster, so again, you can go ahead and pause, rewind, and all those things, okay? So you can take it a bit slower if I'm going too fast. And then the next thing we do, again, just following our formula, the next step is square it. So x minus m squared. So negative 1 squared, we get 1. 1 squared, we get 1. 3 squared, we get 9. Negative 3 squared, we get 9 as well. So the next thing our formula tells us is we need to add all of these, okay? The sum of. So we get 9 plus 1 and 9, we get 20. So st squared equals 20 over, again, n, which is 4 in our case. And we get 5, okay? So this is our variance, okay? st squared equals 5. Now the next thing we do is we do go for our standard deviation. Now that's what we want, okay? So this is the formula up here. SD equals square root of SD squared. So I wrote it down over here as well. So SD equals SD squared, the square root of SD squared. So SD equals, we get 2.24. And again, I always like to box in my answer so I know that's what we're looking for, okay? So now we have all we need. So to change our raw scores, again, our raw scores being, again, this x into z-scores. Now we have our x, our m, and our standard deviation, which we just got. Okay, so now this is the formula we're using. We're switching all of our raw scores to z-scores. So this is the formula again. Look at this. Now, z equals 4 minus 5. Again, this is our first x, which is, again, the one up here. Well, we're doing, again, all of these numbers right here. So it's 4 minus 5, and then we divide by our standard deviation, which we got was 2.24. So for the first one, we get negative 0.45. Make sure, again, that you're very careful not to forget those negatives. For the second one, it's 6 minus 5 over 2.24. Now we got 0.45. Make sure, again, that you don't forget the negatives or positives. 8 minus 5 over 2.24, 1.34 for our third one, and our last one is a raw score of 2 minus, again, our mean, which is the 5, and then we divide by our standard deviation of 2.24, and we get negative 1.34. So all of these are our z of x, okay? Now, that's just for that first part right here, okay? So we did those already. Now let's move on, and now we have to do the same thing, everything we just did right now for y, okay? So now let's do y. All this we just did again now with the y. So we have a 0, 1, 3, and a 0. So here at the bottom, I went ahead and did that again, the same thing, but I used the y just so I won't get confused. So our n again is 4. Our mean formula is the sum of x over n. So we have 0, 1, 3, and 0. We add all of those and we get 4. And then we divide by n, which is again another 4. So our m equals 1. So now we have to do our standard deviation, variance formulas. So here's the formula. We need to do SD squared equals the sum of x minus m squared minus n. So again, these are our x's, and this is minus the mean. So 0 minus 1, 1 minus 1, 3 minus 1, and 0 minus 1. So we get negative 1, 0, 2, and negative 1. Now we square it. Negative 1 is 1, 0 squared is 0, 2 squared is 4, and negative 1 is 1. Now, again, following our formula, it says the sum of x minus m squared. So we add all of them, 4 plus 1 plus 1, we get 6, and then we divide by n, which is 4, okay? So our variance is going to be SD squared equals 1.5. Now to get our standard deviation, we do SD equals the square root of SD squared, which we get SD equals the square root of 1.5, and we get a standard deviation of 1.22. And again, make sure you are rounding 2 decimal places, okay? So we get 1.22. Now, again, now we have all our information that we need to change our raw scores to z-scores. That's why we do this, okay? So now we have our standard deviation. So now we plug it into our formula. Again, our z-scores. Z equals the x minus m over our standard deviation. So again, the first number you'll see is our raw score. If you go back, it's a 0, a 1, a 3, and a 0. So 0 minus 1 for the first one, and then divide by 1 our standard deviation, which we got a 1.22. So for the first one, we get a negative 0.82. Second one, 1 minus 1, which is a 0, divide by 122, we get 0, okay? Next one, 3 minus 1, we get 2, divide that by 1.22, we get 0.64, 1.64. And then our last one is 0 minus 1, which we get a negative 1 over 1.22, and we get, again, don't forget the negative sign, it's right there, negative 0.82. So that's our z-scores for y, okay? So now we got all our data. Again, our z of x up here, and our z of y at the bottom. So the next thing we do, now we're to get our correlation coefficient, which is our r, we're going to use this formula. R equals the sum of the cross products of zx, zy over n. So I wrote that down here. Don't get confused with all this other numbers on the top, okay? All those numbers at the top are just my x that I did before, okay? So all those, you can look at them if you want, but again, all of these are just the data that I worked out for z of x, but on paper. So this is actually much more easier for me, and I'll just explain it, okay? So look at the bottom right here. So this is what we're looking at, okay? So now I wrote down my z of x and my z of y, which we got, okay? These are z-scores for x and our z-scores for y. So again, plugging it into the formula, we have R equals the cross product of Zx, the sum of the cross product of Zx, Zy over N. So again, now we multiply negative 0.45 times negative 0.82, and we get positive 0.37. 0.45 times 0, we get 0. 1.34 times 1.64, we get 2.20. And then the last one, we get negative 1.34 times negative 0.82, we get 1.10. It's a positive 1.10. So that's our cross products of Z of X and Z of Y. Now all we do, again, our formula says the sum of, okay? So now we need to add them. So that's why I put a plus sign right here. So when we add them, again, you can use your calculator, or if you do it like this, just make sure that you align the decimals, okay? So you won't make a mistake. So we get 3.67. So that's going to be our top part of our formula. R equals 3.67, and then we divide by N. And our N, again, always look at it, it's going to be 4 right here. So R equals 3.67 over 4, and our answer is R equals 0.92. 0.92. A positive 0.92. And what does our R tell us? Again, the R of a correlation coefficient tells us the relationship, the strength, and the direction, okay? The correlation coefficient, again, make sure you make a note of this and remember this, is it ranges from positive 1 to negative 1. So as you can see, it's very, very close to a positive 1, which makes this a strong positive correlation, okay? A strong positive correlation with a 0.92. Now, if for whatever reason you get like a 1.92 or 1 point something, it's wrong, okay? You did something wrong, so you go back and check your work, okay? Our R should always range from negative 1 to positive 1. So if you ever get something higher, it's wrong. I can tell you that already, okay? So make sure you go back and double check your work. So that's why I always double check my work and show my work so I know, hey, where did I go wrong? And it can even be just as simple as a negative sign that you forgot. So try to make it very clear. Make sure you have enough space to work out your problems. If you have to use more than one page, again, I recommend it. So this is how we do, again, a correlation coefficient, and this is going over number 5 in our midterm review.